Hi, my name is Ingrid McCarthy and I'm the Education Outreach and Communications Manager for ASTRO 3D, which means I'm the perfect person to take you through a very fast 5-minute journey through the universe 13.7 billion years ago to now. I work for the ARC Centre of Excellence for All-Sky Astrophysics in 3 dimensions. Bit of a mouthful, but we call it ASTRO 3D. Oh, it's already in a minute. So I'm going to basically be... Can I stop it from doing automatic? Okay. So we're using the very best in radio, optical, and also throwing in a bit of big data and supercomputing power to unlock the secrets of the universe. Our director is Lisa Cooley, it's Female Innovation, so I'm going to highlight some of our amazing female astrophysicists that we have. So let's go back to the beginning, well, nearly the beginning. So 13.8 billion years ago, 13.8 light years ago. Just after the Big Bang, we had a period of time where hydrogen atoms started to coalesce and form, and much like a Canberra fog, they're really difficult to see through. They don't let light through, but they do emit a radio wave, and we can listen to them. Let's go. Oh. So this is Kath Trott from Curtin Uni and Rachel Webster from Melbourne University, and they are leading the field in this sort of analysis. So this is our radio telescopes at the Murchison Wide Field Array out in the Western Australian desert. The signals are so faint from they're so far away. So what we're doing is we put them in an array, and then we listen to the radio waves that are coming from the hydrogen. And for the very first time, we're actually able to get a sense of what is happening in this cosmic dark ages, the epoch of reionisation. The red stuff is the hydrogen, and what we're finding is that the little white things that start to appear are the very first stars. And what they're doing is they are ionising, ripping the electrons off that hydrogen and making the universe transparent. We can finally see through the universe and start to see the first stars and galaxies shining and twinkling. So this is the data that comes from those telescopes, and it is now being pumped through a supercomputer, and this is our computer model that we have. And then there was light. So at this point in time, we can actually see light travelling through the universe for the first time. But it's still a really long way away. So what we have is 2 of our researchers are experts in this field. This is Rachel Livermore, again from Melbourne University, and Chin Chin Yuan from Swinburne University. And what they're doing is they are using a light telescope, Hubble, and it's out in space, and they're using a ground-based telescope, the Gemini telescope in Hawaii, to look back at these very early galaxies. They're actually using galaxy clusters, which pull gravity, means the light from really far away can reach these big, powerful telescopes. So they're actually analysing and seeing the older spiral galaxies in the universe and starting to understand a little bit more about some of the very bright early galaxies. So now we move back to, we're getting a bit closer in time, and we're using radio telescopes. These ones are, again, out in the Western Australian desert because we need to listen carefully, but we're only 7 billion years ago now, not 13.7. And this is the ASCAP telescopes. And here we have Elaine Sadler and Barbel Korobalski. Elaine's from Sydney Uni, Barbel's from CSIRO, and they are surveying, using the ASCAP telescope to survey 2/3 of the sky. So they're actually looking at hydrogen in galaxies, and they're actually able to get an idea of 3D of the shape of them. Then we're getting really close to our nearby universe, and here is an optical telescope out at Siding Springs with everyone's favourite astrophysicist Brian Cox there. But it's not just a telescope. We put fibre optics on that telescope, and from that, for every pixel of light that we see, we're also able to see what the stars and the galaxies are made of. And that's Julia Bryant from Sydney Uni, working with the optical fibre bundles, and Carolyn Foster, also from Sydney Uni. So they had 2D pictures of galaxies, 3,600 of them. Then they're able to see what's happening with in the galaxies, so whether they're moving away or forward to us. and also what's happening with the gases, and they don't always match up. So they're producing lots of exciting results now. Okay, so moving forward, we're able to...